Welcome to This Explainer. Okay, today we're going to completely shatter your preconceptions about extraterrestrial life. We're diving into the terrifying, totally mind-bending possibilities of the cosmos. You know, for decades, we've pointed our telescopes up at the stars, hunting for even the faintest signals of life. But what if we've literally been looking for the wrong thing this entire time? Today, we're stepping way outside the comfortable, familiar boundaries of biology as we know it to uncover what scientists actually call shadow biology. So, let's start by diving into a really simple question, one that instantly exposes a massive critical flaw in humanity's search for the unknown, and that is our deep-seated Earth-centric bias. I mean, when we gaze out into the universe, we're overwhelmingly just hoping to find a reflection of ourselves, right? But the cosmos is infinitely strange, and the laws of chemistry tell us that biology definitely isn't limited by our own human imagination.
Let's jump into part one, the carbon bias.
See, we just naturally assume our biology is the absolute universal rule. It's like our own planetary metrics have trapped us in a tiny box. When astronomers look for habitable planets out there, they're basically looking for a specific checklist. We call it the Earth 2.0 paradigm. We want carbon, obviously, because it easily forms complex chains with up to 4 other atoms. We absolutely demand liquid water as a solvent, oxygen to breathe, and, nice comfortable temperatures hovering right around 70 degrees Fahrenheit. We are totally limiting our search to biological carbon copies of ourselves, completely ignoring the fact that the universe offers this vast, chaotic canvas of chemical possibilities.
There's this fascinating discussion on Reddit that absolutely hits the nail on the head regarding this problem, anthropomorphism. Pop culture has essentially conditioned us to expect humanoid aliens. We just expect them to have 2 eyes, a mouth, and limbs, mostly because that's what makes evolutionary sense right here in Earth-specific environment. But guys, that is a dangerous assumption. Thinking that a completely separate entity evolving on a totally different planet under completely different physical pressures would somehow still end up looking like a Hollywood extra? That's wildly optimistic.
Which brings us to part 2, the silicon machine.
Okay, so think back to chemistry class. Silicon sits right beneath carbon on the periodic table, and it actually shares that crucial ability to form stable bonds with 4 other atoms. It can build the exact same kind of complex 3-dimensional molecular chains that are absolutely required for life. But here is the terrifying twist. While a carbon organism, like us, breathes out invisible carbon dioxide gas, a silicon-based creature would exhale solid silicon dioxide. Yeah, you heard that right. That's sand, or glass. Just imagine a biological process that literally exhales solid crystals. Plus, silicon bonds are incredibly rigid, which means these hypothetical organisms could survive in extreme heat and highly acidic conditions that would instantly vaporize human biology.
And I want to be clear, this is not just science fiction. We are looking at actual, peer-reviewed quantum chemistry models of silicon-based exobiological molecules. They're known as ASI and CSI. Using advanced Hartree-Fock calculation methods, scientists have actually proven that stable, alternative molecular chains based on silicon are mathematically and chemically viable. They possess the exact electrical charge distribution necessary for complex biochemical interactions. The building blocks are completely real.
So here's the absolutely crucial point. We often dismiss silicon because its bonds break down in liquid water. But whoever said alien life needs water? While carbon biochemistry breaks down entirely in harsh extremes, silicon could utilize molecules like polysolanols. Basically, these are the silicon equivalents of sugars, and they remain remarkably soluble and stable even in cryogenic liquids, like literal liquid nitrogen. What looks like a fatal flaw for silicon here on Earth actually becomes a biological superpower in environments that would look like absolute hell to us.
Let's explore those places in part 3, the extreme environments.
Instead of just endlessly hunting for an exact Earth twin with liquid water, imagine a shadow biology perfectly adapted to drink cryogenic liquid methane on Titan. Or maybe one that crawls through the toxic, highly acidic clouds of Venus. The moment we expand our definition of what a viable liquid solvent can be, the number of potentially habitable worlds in the universe just completely explodes.
Let's zoom in on Saturn's moon, Titan, for a second. It has these massive hydrocarbon lakes of liquid methane and ethane that are over 100 meters deep. The whole moon is locked in a cryogenic deep freeze. A silicon-based entity living there wouldn't even be distantly related to us. It would represent a second, completely separate genesis of life. And because of that extreme cold, their biological processes wouldn't rely on the fast covalent bonds we use. Instead, they might rely entirely on hydrogen bonding. That would result in a life form operating at a frozen, truly glacial pace. We're talking about an organism where a single thought or heartbeat could literally take years.
On the complete flip side, let's look at Venus. The surface down there is hot enough to melt lead, sure, but high up in the temperate cloud zone, life could be suspended right there in droplets of concentrated sulfuric acid. Any biological entity swimming through those clouds would be incredibly bizarre. I mean, they'd need acid-resistant outer walls or some sort of acid-neutralizing biology. And because they'd have absolutely no access to the surface crust, they'd suffer from an extreme lack of the metals we usually need for traditional metabolism. They would literally have to rely on falling meteoritic space dust or explosive volcanism just to harvest the trace nutrients they need to survive.
Now, here is a truly unsettling thought. We might not even need a spaceship to find this stuff. Astrobiologists theorize that there could be an unrecognizable shadow biosphere hiding right now in the deep crust of our own planet. We're talking about a hypothetical microbial ecosystem coexisting alongside us, but utilizing radically different biochemical and molecular processes. It would be utterly invisible to our current scientific instruments because, well, we simply don't even know what chemical signatures to look for. This brings us to part 4, the incomprehensible first contact.
Let's do a stark reality check here. We have studied whales for decades, right here on Earth, right? They are fellow mammals, they literally share our evolutionary tree, and yet we still don't really understand them when they sing. Trying to casually chat or, trade math equations with something that evolved 100 billion light years away, a breathing crystal formation, it's probably going to be impossible. It makes our current expectations seem wildly, maybe even dangerously optimistic.
If we actually encounter true shadow biology, we have to throw all our sci-fi expectations completely out the window. They are not going to have human-like faces or familiar sensory organs. They won't have vocal cords or use sound-based language. Heck, their atmosphere might not even allow for sound. And ethically, they might completely lack any binary concept of good and evil, operating totally outside our evolutionary constraints of empathy or competition. Some physicists even propose the existence of high-energy plasma-based entities born in the outer atmospheres of stars, literally made entirely of charged particles.
This leads us to something we can call the Solaris effect, drawing from Stanislaw Lem's classic science fiction novel. First contact might not be this dramatic, cinematic meeting of minds. It might just be us staring at a massive, living, crawling metallic structure or some giant gelatinous ocean, and fundamentally failing to even categorize it as alive. It's an encounter so completely devoid of human connotations that it just becomes a mirror, reflecting our own limited understanding back at us.
Actually, scratch that. Given the extreme time and incredibly hostile conditions required for interstellar travel, our very first contact is most likely not going to be biological at all. It will likely be a hyper-advanced, spacefaring artificial intelligence. Think about it. A machine species created millions of years ago, perfectly adapted for the hostile vacuum of space. An entity that shares absolutely zero evolutionary traits, zero biological imperatives, and zero emotional vulnerabilities with humanity.
So I want to leave you with this final provocative thought to ponder. As we gaze up into the cosmos, desperately hoping to find a reflection of ourselves, a reassuring Earth 2.0, are we genuinely ready to face an intelligence our minds can't even comprehend? Are we truly prepared for the terrifying awe of the incomprehensible staring back at us? Thank you so much for exploring the shadow biology with me in this explainer. Keep questioning everything and keep looking up.